In this example, we want to know if there is bias in jury selection. So we take a look at a sample of 870 people in Hidalgo County, Texas, who were selected for grand jury. And it turns out that out of the 870 people, 39 of them were Mexican Americans. So we want to estimate the actual proportion of grand jurors in this county, right, who are Mexican Americans. So let's let P be the proportion of grand jurors who are Mexican Americans. And we're going to build a 99% confidence interval to estimate for P, okay? All right, so I'm going to start by just writing down all the information that I've just read here. And let me grab my pen. So our sample size N is 870 people. And in this particular problem, we're actually given our sample proportion P hat, which is at 39%. So always convert that percent to a decimal. And then before we move forward, we should go ahead and calculate X, which is the number of jurors who are Mexican American. So how do we calculate that value X? Well, if we know that our sample size is 870 and 39% of them are Mexican American, and X represents the number who are Mexican American, then X is just simply 870 times 0.39, which tells us that out of 870 jurors, approximately 339 of them were Mexican American. Okay, all right, so now that we have that information, let's also write down our confidence level. So our confidence level in this particular problem, we're building a 99% confidence interval, so that confidence level is going to be 0.99. Therefore, our alpha, which later on you'll learn that alpha is called your significance level, that's just 1 minus your confidence level. So alpha is 1 minus 0.99, which gives us 0.01. And then go ahead and take alpha and divide it by 2. So that's going to be the red shaded region in the tail area of the normal distribution, the standard normal distribution. So 0.01 divided by 2 gives me 0.005. Okay, so that's going to help me find my critical value. So again, the critical value, the notation we use is z sub alpha divided by 2. So in this particular problem, we're looking for a z-score that separates an area of 0.01 divided by 2, or a z-score that separates an area of 0.005 on the right tail. So let me draw that distribution real quickly so that you can see what it looks like. So the standard normal distribution, 0 is in the center. I'm looking for the z-score that separates an area to the right here of alpha divided by 2. So alpha divided by 2, that's 0.005. Okay, so to find that z-score, you're going to use inverse norm. So just go to your calculator and use inverse norm. You're going to type in the area to the left. So the area to the left here is just 1 minus alpha divided by 2, which is the same thing as 1 minus 0.005. And you can simply just type in 1 minus 0.01 divided by 2, and your calculator will do the math for you. And then we're going to put in 0 and 1 for the mean and the standard deviation. And then when you press enter there, you're going to get 2.58. So we're going to use that critical value to now find the margin of error. Okay, so the margin of error, that formula is the critical value, 2.58 times the square root of our p hat, which is 0.39, times 1 minus p hat, divided by our sample size, which is 870, and it's going to give us a margin of error of approximately 0.042. So now that I have that margin of error, I'm going to use this notation, p hat minus my margin of error is less than the actual proportion of Mexican Americans for the county, and that value is going to be less than p hat plus my margin of error. Okay, so let's go ahead and get our lower confidence limit here. So that is 0.39 minus 0.042 is less than p is less than 0.39 plus 0.042. So our lower confidence limit is going to be 0.347, and our upper confidence limit, so our upper confidence limit here is going to be 0.432. So let's interpret this solution that we came up here with, this confidence interval. So The results of the confidence interval tell us that if there is no bias in the selection of grand jurors, then we should expect the proportion of Mexican American grand jurors to be closer to 0.791 or closer to 79%, which is the actual proportion of Mexican American residents in this county. But since our confidence interval estimates the proportion of Mexican American jurors to be no more than 0.432, so no more than about 43%, which is nowhere close to 0.791, so nowhere close to 79%. Therefore, we can conclude that there is bias in the selection of grand jurors. Now, if you want to use your graphing calculator to get this confidence interval on your calculator, you're going to use the function 1 proportion z interval, where you're going to type in your n value, your x value, your x value, which is 339, and your confidence level. And then once you type in all that information, it should give you a similar confidence interval. But it'll write it like this using the open parentheses, 0.347, comma, 0.432.